yesterday we left off on example 4, and we're going to explore the effects of changing dimensions here. So it says the diameter and the height are divided by 3, and then we're going to describe the effect on the volume. Now, we did something similar, and we talked about what our pattern was going to be. Okay, so if you are dividing by 3, then, can any of you tell me what the pattern is? What the pattern's going to be? Remember, there was a special relationship when we were finding the volume? Yes, good. Okay, it's going to be your factor cubed. Okay, so when you're dividing by 3, you can just use your knowledge. You can also find the volume of the original and the old one, and you'll see that this is true. The new volume will be divided by 3 cubed. And again, it's cubed because this is the volume. Okay, so 3 cubed is going to be 27. Okay, so the way that we would write this is we would say the new volume will be 27 times smaller, or you could say 1/27th of the original volume. Okay, so those are the 2 ways that you would write your answer. You'd either say 27 times smaller or 1/27th of the original volume. Okay, so note when you're dividing by 3, okay, that's the same thing as multiplying by the reciprocal. And the reciprocal of 3 is 1/3. So if you cube 1/3, you cube the top and you cube the bottom, which is where we're getting that 1/27. Okay, so it is like you are multiplying by the 1/27. Okay, and then again, if you didn't remember that rule, you could find both the original and the new volume and then just reduce that fraction. And when you reduce the fraction, you'd get 1/27. All right, now for example 5, we're going to find volumes of composite 3-dimensional figures. So find the volume of the composite figure, and then we're going to round to the nearest 10th. Okay, so we're doing the volume, not the surface area. So the total volume includes everything that's inside. Okay, it's what you would fill up the cone with. So when you're finding the volume, it's going to be the volume of the top cone plus the volume of the cylinder plus the volume of the bottom cone. Okay, so all of those together. Now, because these are all overlapping perfectly, the top cone and the bottom cone are going to have the same volume. Okay, if they have the same radius, and the same height. But notice how these two, their heights are different. Okay, so if these 2 heights were the same, you could just multiply that by 2. This height is 70, this height is 40, so we are going to have to find both of those separately. Okay, so my first step is going to be to find the volume of the top cone. So the volume of your top cone is 1/3 pi r squared times h. And they do have the radius clearly marked for you here. Okay, and then then you also have to figure out what the height is. Now, notice that the 70 goes from the top of this cone to the bottom of this cylinder. Okay, so we have to figure out what the height is. Do you guys have any ideas on how we can find that? Okay, so you can see the height of the cylinder is 35. So if you do 70 minus 35, what do you get? 35. So from here to here is going to be 35. Okay, so this is going to be 35, and then this is already labeled as 35. So that's where you're getting your height from. Okay, and then we're going to leave this in terms of pi. Okay, so I'm going to do 21 squared, multiply by 35, and then if you're multiplying by 1/3, you can also just do what? Divide by 3. So if you're dividing by 3, you're going to have 5,145 pi, and that's going to be the volume of the top cone, or I'll say TC. Okay, now we're going to find the volume of the cylinder. Okay, so your volume of a cylinder is pi r squared times h. And again, your radius of the cylinder is going to be 21. And then we see that the height is labeled as 35. So your volume of the cylinder is going to be 15,435 pi. Okay, and then the last one is the volume of the bottom cone. So I'm going to use the same formula that I did in step 1. The only difference now is going to be the height. Okay, so the radius is the same, but the height of this one is 40. So the volume of the bottom cone is 5,880 pi. Okay, so now I'm going to do the total volume. Which would be adding up the top cone, the cylinder, and the bottom cone. And I get a whopping 26,460 pi. And then it says to round to the nearest tenth for this one. Okay, so we are going to multiply that by pi. And you get 83,126.54. Okay, so that 4 is going to keep this at 83,126.5. And then because it's the volume, our units are going to be centimeters cubed. Okay, in just a minute, I'm going to get you guys situated for your quiz. When you are done with your quiz, okay, I will come and pick that up from you, and then you can have the rest of the time to work on